Welcome to another video. Today we're going to be talking about the rational root theorem. So the word rational, notice that it has the word ratio in it, and we know that a ratio is just a fraction. So today we're going to be composing fractions to figure out what the roots are. And some other words for roots are x-intercepts, solutions, zeros. Those all mean the same exact thing. So this theorem allows us to find the possible rational roots. They're not all going to work, so we're going to test them by graphing them in our calculator and seeing what the x-intercepts are. You may also discover that there are more solutions in the graph than in your list of possible zeros. And this is because there are other terms in between the leading coefficient and the constant number that may create other zeros. There are other ways to find all the solutions, such as factoring or graphing, but for this, we're only going to select from our list of possible zeros because that's the point of the rational root theorem. So let's do some examples. So starting with example 1, all you're going to be doing is dividing the leading coefficient by the constant number. So the leading coefficient refers to the term that has the highest exponent. In this instance, that will be the term with the x cubed. Now the constant number is the number that has no variable. In this equation, it is -7. Okay, so this one is A, and this one is C. So I'm going to put A equals 2 because it's only the coefficient. You're not going to put the variables. So A equals 2 and C is equal to -7. Okay, now for each number A and C, you're going to list all the possible numbers that you can multiply to get that number. So all the factors of that number. So the only numbers you can multiply to get 2 would be 1 times 2. Now, you could do -1 times -2, or you can do +1 times +2, because two negatives make a positive and two positives stay positive. So, because of that, we're going to put plus or minus 1 and plus or minus 2. And that will account for the fact, again, that you can have negatives that make a positive value. There are no other numbers that you can multiply to get 2 other than 1 and 2. So for A, we are done. Now for 7, it will be the same thing. You can only have 1 times 7, right? So it could be +1 times -7 or -1 times +7. So to take into account that you can have different possibilities, just do plus or minus, and there are no other numbers that you can multiply to get 7. Okay, so now that we have this, we're going to start listing the possible rational zeros. Okay, so the possible rational zeros you're going to find by doing C divided by A. Now, this is not on your formula chart, so it's important that you remember this one. So C divided by A is what we're going to be doing. And you're going to have a bunch of different options. So the way that I like to start is with the first C value, and then I'm going to work up and then over here. And then that will make sure that I have every single possibility because you don't want to miss one by accident. Once you're done with this one, then you're going to go with the next C value and make fractions with all the A values. So let's put that into practice. So the first C value is 1. So I'm going to do +1 over positive plus or minus 1. But 1 divided by 1 is just 1. So I actually don't need to write this as a fraction. I can just do plus or minus 1. Okay, so that takes into account these two values right here. Now I'm going to move into C divided by A, but the other A value. So 1 divided by 2. Well, plus or minus 1 divided by, plus or minus 1/2. Okay, so now we had 1 divided by 2, which is 1/2, and you just keep the plus or minus. Okay, so now that we've done C, the plus or minus 1 of C with both of the factors of A, now we can move on to the other factor of C, which is 7, and we're going to do 7 divided by 1. So plus or minus 7 divided by 1, we can simplify that to just 7. So it will just be plus or minus 7. And then the next one will be 7 divided by 2. So plus or minus 7 divided by 2. Okay, so we have a total of 8 possible zeros because each of these has a plus or minus, so it's actually 2 numbers. So there's 4 possibilities here. So now how are we going to figure out which ones are the actual rational zeros? So that's the next step. So all we're going to do is graph it in the calculator, and we're going to see what numbers line up with our list of possibilities. So we're going to open a graph, and we're going to type 2x cubed minus 11x squared minus 20x minus 7. Okay, then you're going to press enter. Now again, the roots refer to the zeros or the x-intercepts. So I'm going to do analyze. So that's menu, analyze, and then 0. And we're going to go one by one. So remember that you get this dashed line, you put it to the left of the first 0 and then drag it to the right. You don't want to go too much because then you don't get, you only get one at a time. So just do one at a time. So the first 0 is -1. Let's find the other one. So this time you want to start in the middle so you can get that second one. So we have negative 0.5. I'm just moving it so we can read it better. It's being difficult. Okay. It's like too many things happening. I'll put it up here somewhere. And then let's do the last one, which is all the way over here. So you drag that first line all the way to the other side and then over here. So we have -1, -1/2, and +7. So those are the 3 roots. So let's see if those are in our options that we had listed prior. Okay, so the first one was negative, oops, not Airbnb. So the first one was -1. So we're gonna write the rational zeros as a set in curly brackets. So we did have -1 in our list. So we just don't use the +1 because it was only -1. And then it was also -1/2, which we do have in our list as well. You just won't use the +1. So -1/2. And then the last one, which was +7, which is also in our list, but just a positive side, not the negative. So there were 3 zeros at -1, -1/2, and 7. So these are the rational zeros. And again, so you list all the possibilities, and then you're just going to select the ones that appear on the graph that also appear on your list of possibilities. Okay, let's try another one. So we have A and C. So A is the one that has the leading coefficient. A is where the term with the highest exponent is. So x cubed is the biggest exponent. And then C is the constant number that has no variable. Okay, so A is 11 and C is -3. So what numbers can you multiply to get 11? The only options there are 1 and 11, but again, we're going to do plus or minus. So it'll be plus or minus 1, plus or minus 11. Now for -3, the only numbers you can multiply to get 3 are 1 and 3. So plus or minus 1 and plus or minus 3. Okay, so now we're going to list the possible rational zeros. And we're going to divide C divided by A. Okay, so start with the first C and then divide all of the A's, and then do the second C and divide all of the A's. So that way you don't miss one by accident. Okay, so the first C and A values are 1 divided by 1, which just equals 1. So plus or minus 1. The second one is 1 divided by 11. So plus or minus 1 over 11. Now that we're done with this 1, we're going to move to the 3. So now we're at 3 divided by 1. 3 divided by 1 is just 3. So I'm going to just do plus or minus 3. And then we have 3 divided by 11. So plus or minus 3 over 11. Okay, so 8 possibilities here. Now we're going to graph it to see which ones actually appear on the graph. So that was 11x cubed minus 21x squared minus 35x minus 3. Okay, and so you get this, and we're going to analyze those zeros again. So menu, analyze 0, and start one by one. You can do them all at the same time. So always start a little bit to the left of the point you want, and then drag it to the right. Okay, so there's one at -1. Let's do it again. Let's find that middle one. So drag your line, And then we're going to have to convert that to a fraction because I don't know what that is. And then the last one over here, and then drag it to the right. Okay, so we have one at -1 and +3, and then that negative 0.90091. We can figure out what that is as a fraction. Okay, so let me open up a graphing calculator. Sorry, a regular calculator, and I'm gonna put negative 0.091. Negative 0.091. Menu number approximate to fraction. Okay, it might have been rounded. So let's just do our fractions that we had. So our fractions were 1/11 and 3/11. And let's see which one is negative 0.91. So let's start with 1/11. We got to convert that to a decimal. Well, here, let me do it again so it's less steps. So 1/11, if you want to have it be a decimal before, and you don't have to do any extra steps, all you need to do is add a period, a decimal to either the numerator or the denominator, and it'll automatically make it into a decimal. So 1/11 is 0.091. So you can see it actually was rounded on the graphing calculator. Let me show you 3/11 as well. So 3/11 is 0.27. So the root that actually showed up that was equal to negative 0.091 would be the negative 1/11. So from our list of possible zeros, the real answer, the rational zeros, again, we're going to write this in curly brackets. So the first one on the graph was -1. And then the negative 0.091, which was the negative 1/11. And then we had that +3. Okay, so we have 3 roots. And again, these are all in our list. So we have -1, negative 1/11, and +3. Because in the event that there's a zero that is not in our list of possible zeros, we're not going to list it as an answer. It has to be in our list of possibilities in order to be an answer. So let's try another one. So again, look at the term that has the highest exponent to find the leading coefficient. We have negative 6x cubed, and then the constant number is the one that has no variable. So A is negative 6, and C is +8. Okay, so what number can you multiply to get 6? So you can do 1 times 6, but you could also do 2 times 3. So this one has more factors. Okay, so you can do 1 times 6 or 2 times 3 to get 6. And then for 8, it'll be similar. So you can do 1 times 8. So plus or minus 1 or plus or minus 8. But you could also do 2 times 4 and still get 8. Okay, so this one we're going to have a lot of possible zeros because there are so many numbers. So let's start listing those possible rational zeros. So you're going to start with the first C. So don't worry about these right now. You're going to do 1 divided by 1, 1 divided by 6, 1 divided by 2, and 1 divided by 3. And those are going to be your first ones, and then we're going to start doing that for each 8, 2, and 4. Okay, so 1 divided by 1 is just 1. Then you got 1 divided by 6. Then you got 1 divided by 2, and 1 divided by 3. Okay, so those are all the possibilities with the 1. Now we're going to move on to the 8. So we're going to do 8 divided by 1, 8 divided by 6, 8 divided by 2, and 8 divided by 3. Now, if you can reduce the fraction, absolutely do that. So the first one, which is 8 divided by 1, just simplifies to 8. Okay, so that's 8 divided by 1. The next one is 8 divided by 6. You can put that in the calculator and see what that reduces to. 8 divided by 6 reduces to 4/3. Okay, so then we got plus or minus 4/3. Now we've done this one, so now we're going to do 8 divided by 2. Well, we know 8 divided by 2 is 4, so we got plus or minus 4. And then the last one will be 8 divided by 3. I'm going to start doing them down here because I ran out of space. Oh, I actually didn't. I have more space. I'll move this over here. Okay. So So far, we've done all the 1s divided by all of these, and we've done the 8 divided by all of these. Okay, so now we're going to move on to the 2. So we're going to do 2 divided by 1, 2 divided by 6, 2 divided by 2, and 2 divided by 3. Okay, so starting off with the 2 divided by 1, that simplifies to just 2, so plus or minus 2. And then we have 2 divided by 6. Let's see what that reduces to. 2 divided by 6 is 1/3. But notice that we already have 1/3 in our list. So you don't want to duplicate the possible zeros if it's already there. So even though this is also 1/3, we already had 1/3 from the 1 and the 3. So we're not going to repeat it. We're just going to move on. Then we have 2 divided by 2. 2 divided by 2 is 1, and we already had 1 because we had done 1 divided by 1. So we're not going to list that one either. And then the last possible for the 2 was 2/3. And let's see, we don't have 2/3 yet, so that will be another option. So plus or minus 2/3. Okay, now that we've done all of the 2's, we're going to move on to the 4. So we're going to do 4 divided by 1, 4 divided by 6, 4 divided by 2, and 4 divided by 3. So with the first possible option, 4 divided by 1 is 4, but we already have 4, so we're not going to do that one. And now we're going to do 4 divided by 6, and that does reduce, so let's see what it equals. 4 divided by 6 is 2/3, but we already have 2/3 from the other one, so we're not going to use that one. And then we have 4 divided by 2, which equals 2, and we already have that one, so no need to list that one again. And then the last one, which is 4 divided by 3. Let me just make some more. Oh wait, we already had 4 divided by 3 as well. 4 divided by 3 is right here already. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20 options. Because remember, you got the plus and the minus, so it's always times 2. So there are 20 total options there. Okay, so now we're going to graph it so that we can find the rational zeros. Okay, so open up a new graphing calculator, and we're going to do negative 6x cubed plus 5x squared plus 18x plus 8. Okay, and this is what we get, and you can zoom in so you can see that there are 3 zeros. So let's start analyzing those. So menu analyze 0. So the first one is at negative 0.851. Let's find the middle one, negative 0.667, and then the last one is 2.35. Okay, so obviously these are all decimals, so I'm going to figure out which of all of our fractions that we have equal these numbers. So let's start with 1/6. Oh, sorry, I forgot to put the decimal in the denominator. 1/6 equals 0.16. Was that one of the numbers? No, it was not. So let's try some more options then. We also had 1/2. Well, we know that's 0.5. Let's try 1/3. 0.33. Was that one of them? Nope. Let's go back. The other fraction was 4/3. 1.33. Is that on there? Nope. Okay, let's come back. Then we had 8/3. 8 divided by 3. 2.667. Is that one of the options? Nope. We also had 2/3. 0.667. Was that on there? Okay, that one is on there as a negative value, so it's the middle one. So we went through all the fractions. Obviously, these are not whole numbers, so it's not going to be the whole numbers, which are 1, 8, 4, 2. Those are not on here at all. So that's why I was only testing what the fractions were as decimals, and the only fraction that showed up was the 2/3, which is equal to negative 0.667. So even though there were 3 total roots here, we're only going to select the one that's in our possible list of zeros, which was the negative 2/3. Okay, so I'll make a note of that so you don't forget when you look back. So even though there are 2 more roots, on the graph only pick from our list of possibilities. Okay. Okay, let's do the last example. So again, circle A and C. So A is the one that has the highest exponent, which would be 9x cubed. The constant number has no variable, which is -1. So A is equal to 9. So the numbers that multiply to 9 would be 1 times 9, but also 3 times 3. And now you're not going to list it 2 times, only 1 time, okay? But 3 times 3 is 9. And there is no other number, so let's move on to C, which equals -1. The only numbers you can multiply to get 1 would be 1 times 1, 1 times -1, so it'll just be plus or minus 1. So now let's list the possible rational zeros. Okay, and so there's only one C value, so we're only gonna do 1 divided by 1, 1 divided by 9, and 1 divided by 3. Okay, so 1 divided by 1 is just 1, 1 divided by 9 is 1 over 9, and 1 divided by 3 is 1/3. And all of these are plus or minus. Okay, so now let's graph this to see what the rational zeros are. Remember, these are in curly brackets. Let's open up a new calculator sheet. Graphing 9x cubed minus 19x squared plus 11x minus 1. Okay, so zoom in a little bit, and this is where you're going to see. So menu, analyze, graph, and then 0 for the first one. So the first 0 is at 0.111. Now let's see what that other one is. It's at 1 and 0. Okay, so let's figure out which of the two fractions we have equal to 0.111, because we have 1 over 9 and 1/3. So 1 over 9 is 0.111. So that's the one we need. Okay, but notice that the graph, it kind of curved up. So this part right here, oops. So this part right here, it kind of curved up. It kind of like bounced off the x-axis. When it bounces off like that, that's actually going to create multiplicities, meaning that even though it only touches one time, it's technically two roots there. Okay, so well, first let me list the rational zeros. So we said it was 1 over 9 and it was positive, and then we had that positive 1. Okay, as you can see down here in this little image I inserted, if it just goes right through, it's only 1 0. But if it kind of bounces off of the x-axis, that's going to be multiplicity of 2. And if it kind of looks like a x cubed function where it's going through, but instead of bouncing off, it kind of just goes down, that's going to be 0 with multiplicity of 3. So in our graph, and I'm going to sketch it just so you can remember what it looks like, it kind of looked like this. So there was a 0 here and a 0 here, but this one has multiplicity of 2 because it bounced off the x-axis. Okay, so when I list the rational zeros, yes, there were only two numbers, but the 1 had a multiplicity of 2. So I'm going to say 1 with multiplicity 2. Okay. So yeah, that is the rational root theorem. The good news is that I think usually on the test, they usually just ask you for the list of rational zeros. So let me show you, like, this is the sample questions from the ACP, and like number 15, it just says which list represents all possible rational zeros. So you don't necessarily have to go and graph it and then convert the fractions and then see what's on there. You don't have to really worry that much about the multiplicity part. As long as you're able to remember that you have to do C divided by A, that A has the leading coefficient and C is the constant number, and then that you don't forget any of the the options, okay? So some of them on the answer choices, you're going to try to confuse you and do A divided by C. So just you have to remember and study this, that it's C divided by A, because this is not on the formula chart, okay? With that being said, I'll see you in the next video, and I'll see you. Bye.